Okay, so we're on 9-8, which we're going to be talking about how decimals and fractions are alike. We've used decimals before to represent money, or sometimes we use it to represent sports statistics. These are both ways that we might use the decimals. We've already talked about using decimals prior to this, but now we're going to connect it with fractions. How are decimals and fractions similar? Actually, they are exactly the same. Fraction is a part of a whole, and a decimal is part of a whole. So we're going to go ahead and write our title, Fractions and Decimals, and our I can statement. I can represent a decimal as a fraction and a fraction as a decimal. So I want you to go ahead and draw this number line. I'm not going to use it right this second, but if you draw it, you'll have it ready for a little bit later. Make sure that you have it spaced out so that you have plenty of space between your 0 and your 1, similar amount of space between your 1 and your 2, and similar amount of space between your 2 and your 3. Remember, we can't have it perfect because, of course, we are human, and no human is ever perfect. Pause the video if you need to go ahead and get this written down. Don't pause it too long, though. We got to keep moving. Okay, so I'm going to read this part up here. It is up to you whether you write it down or not. I just wanted to be able to show you what I'm reading so that you can think about it. So, Betty made 3 out of 10 shots, or 3/10 of her shots playing basketball. So we know when we're playing basketball, we're shooting hoops. So she shot 10 and she made 3 out of them. So we're going to give 3 fractions that are equivalent. Remember, equivalent means equal to this using the denominators of 20, 50, and 100. So we're going to think, okay, if I have 3/10 here, what do I have to multiply 10 by to get 20? So if we think about this 10 times what equals 20? Well, 10 times 2 is going to get us 20. 10 times 2 is 20. Well, what we do to the bottom, we have to do to the top. So you should have a new number up top here because now you have 3 times 2. So to write an equivalent fraction to 3 over 10, our equivalent fraction is 6 over 20. That means that these two fractions are exactly the same. They mean the same thing. This one's cut into 10 pieces, this one's cut into 20 pieces. That's the difference. They're just cut into different pieces. The more pieces something is cut into, the smaller each piece would be. So if you think about a pizza, if I cut it into 3 pieces, or if I cut it into 8 pieces, think about the size of each piece. That's what happens. But I'm getting an equivalent fraction. Well, to go from there, I need to get to 50. I'm going to go back to my original fraction of 3 over 10, and I'm going to think 10 times what gets me 50? Well, if 10 times 2 got me 20, 10 times 5 is going to get me 50. And then I have to do the same thing up top. So 10 times 5 is 50. 3 times 5 is, on your paper you should have 15. It is an equivalent fraction. It means the same thing. So even though we have different numbers, it just means the things are cut into pieces differently. So 3/10 is the same thing. 3/10 is the same thing as 6/20 is the same thing as 15/50. Well, now we have to think, how do I go from our original fraction of 3/10 to 100 on the bottom? What times 10 equals 100? So we have to do the same thing on top. And we have a new number on top of 30. So these are all equivalent fractions to 3 over 10. So if I were to go from 20 to 100 to come up with an equivalent fraction, I could. 20 times 5 is going to get me a 100. We have to keep that in our head. If we had nickels, there would be 20 nickels in a dollar, because there's 100 cents in a dollar. So 20 nickels, 5 cents each, is going to equal 100 cents. Is this true up top? 6 times 5, is that 30? Yep. We could work backwards too with this other fraction. We could say, okay, well, 50 times 2 is 100, and 15 times 2 is 30. That's how we check our work to make sure we have an equivalent fraction throughout. It's really important that we get, when we're thinking about decimals, that we get either 10 or 100 on the bottom. It makes our life so much easier. Because when I think about decimals, we have our place values here. We have our ones is in front of the decimal. We have our tenths, our hundredths, and our thousandths. Well, tenths, we're going to be comparing with a fraction with 10 on the bottom. Hundredths means it has 100 on the bottom. And what would you guess would be on the bottom of thousandths? You should see a trend. This one would be 1,000. This is how easily we can look at decimals and put them into a fraction form. So if I had a decimal of 0.6, it would be 6/10. If I had a decimal of 72, I have 72 over 100, or 72 hundredths. And if I had, let's say I had 5, 4, 3, I have 543 thousandths. If I had a number here in the ones place, it would just be my mixed number. So let's try this. If we had 4 over 10, because we already have 10 as our bottom number, we can easily put it into decimal form. There's no big whole number in front, so we know that our decimal is going to have a 0 in the 1 spot, and because it's over 10, we know that it's going to go out 1 place after the decimal. So 4/10 is the same thing in fraction form as this in decimal form. 4/10, we would say the same thing. How about this? If I have the decimal 56.56, sorry, what fraction would that become? Well, there's 2 spots behind the decimal, so we have to think what place value that is. If I've forgotten my place value, I can go back in the video and look, or go back in my notes and see. You should have written down your place values. I also have it posted in the room on the whiteboard up front. Our place values in front of the decimal point and our place values behind the decimal point. So, because there's 2, that means that my bottom number to go from a decimal to a fraction should be 100. My top number is going to be the exact number that I see there, so this would be 56 hundredths. Sometimes we're going to have fractions that don't have 10 or 100 on the bottom, like in this case, 4 over 5. I have to figure out a way either to get the bottom number to 10 or 100, and this one's pretty easy because we know our math facts. 5 times what can equal 10? Should be a 2 there, and what I do to the bottom, I do to the top. So then I have 8 on top and 10 on the bottom, and so I have to do a little bit of work here first before I can get to my decimal of 8/10. Sometimes It might be something where you're not even sure how you're going to get that bottom number to be a 10 or to be a 100. For instance, if we had the fraction 3/25. Now some of us might use my quarter idea and think, oh, there's 4 quarters in $1. I can times that by 4 and get 100. It's cool if you get that right away. Some of us are going to get that right away and some of us are not. So here's an alternative method in case you get a fraction like this and you just don't know how to get it to 10 or how to get it to 100 as your denominator. So remember when we were talking about improper fractions and the top number would fall into the house of a division problem? All fractions are division problems. So this 3 would fall into the house like this, and then this would be on the outside. Of course, the bigger number is outside because we're going to get a decimal, something smaller than 1. So we pop that ninja decimal down, pop it up top, and add a 0. Well, how many groups of 25 are there in 30? I can only make one group, and then I divide, multiply, 1 times 25, subtract, and bring down. There's nothing there, but remember I can add zeros until I'm all done. So I bring my 0 down. How many groups of 25 in 50? 2 groups of 25 in 50. 2 times 25 is 50, and we get down here to the bottom with a remainder of 0. So my decimal for 3/25 is 0.12. Okay, so we've been working on our secret number. You've only had one clue so far. So your second clue this week for your secret number is this number is even. So think about your first clue and think about your second clue. You might want to take a guess at the number. You can throw it on Class Kick, and I will tell you if you are correct. Go on over to your Class Kick, use your Class Kick codes. Make sure that you're using the right Class Kick code. Like if you're in Group 2, make sure you're in Group 2 in your Class Kick. And as always, happy mathing.